Good morning, students. Today we'll try to solve numericals from the miscellaneous exercise of the complex number. Okay, from the class 11th mathematics. So let us try numericals from miscellaneous exercise. Okay, we have studied about everything about the complex number, how to find the modulus, how to find the complex, how to find the modulus and argument, and we have studied how to convert them in the standard form and how to find the polar form of the complex number. So we have studied everything about the complex number, but now we'll try to solve miscellaneous numericals from the exercise. Okay, so first question I have. So first question is, we need to evaluate. Okay, we need to evaluate what they have given. I raised power 18 plus 1 upon I whole power 25. Okay, so they have given this. We know what is I is iota, and we also know that the I square value is -1. So now let us try to evaluate it, find its value. How? We can write I raised power 18 as I square raised power 9, plus similarly I can write I raised power 25 as I square 12 into I. Okay, so now that what we can do here, now the next step is, we know I square is -1. Okay, so now here also I square -1. So -1 whole to power 12 into I. It is -1 because we know negative power having negative number having power odd, we got only negative number, plus here we'll have I itself. Okay, so I have this. So now what will be my next step will be, I can multiply as I in numerator and denominator. So it will be -1 plus I upon I square. So it is now I upon I square will be -1. So here -1 minus I will here. Okay, so they have given this. So now one more thing is what we have missed in the question, that is it is cube they have given. Okay, so they have given cube. So now what we can do here, similarly we can take -1 common here, and we have I plus 1 cube. Now we know the formula for a plus b whole cube, that is we have a cube plus b cube plus 3 into ab into a plus b. Okay, so now what we have, -1 I square, I can write as I square into I plus we can take bracket here. Okay, I can write this plus 1 plus 3I square plus 3I. So what will be left with us? -1 minus I plus 1 plus 3I square will be -1. So it will be here, I can write as -3 plus 3I. Okay, so now I know I square, we have -1 to -I, and here we have -2 plus 2I I have. If I multiply minus sign inside, so I got 2 minus 2I. I can take 2 common as, so 1 minus I. That is what we find after evaluating such numerical. Okay, I hope it's understood to everyone. Now let us try to solve next question we have. Okay, so this is the first question which I have solved in the from the miscellaneous exercise. Okay, so now let us move to the second question. What the question says, let us see. It says that, okay, for any two complex numbers that is z1 and z2, we need to prove that. So this is the question I have, and I need to prove this. Z2, the multiple form, Z1, sorry, minus imaginary Z1, imaginary Z2. We need to prove this for any two complex numbers. They are taking Z1 and Z2. So now let us try to solve. Let we consider Z1 is equal to x1 plus I y1 and Z2 is equal to x2 plus I y2. Okay, so we can take such two complex numbers. Now we have, let us try multiply Z1 and Z2. So what I got here, x1 plus I y1, and in multiple form I y. Okay, so they have this. Now what we can do, multiply inside x1 x2 plus I x1 y2 plus I x2 y1 plus, if I take this plus, I have, if I multiply with this, I got I square y1 y2. So what can I write here, x1 x2, there I square minus 1, so it will minus y1 y2 plus, if I take I common, so I got x1 y2 plus x2 y1. Okay, so we understand that a complex number have real number plus imaginary number with I. So it is imaginary number and it is real number. So now what we can do here, that is, now we need to, so we already know that the product of two complex number will be the complex number. So now we have this. So now I can consider that real number of z1 z2, it will be x1 x2 minus y1 y2. So I can say this, that therefore real number of z1 z2, it will be real number of z1 into real number of z2 minus imaginary number of z1 and imaginary number of z2. Hence proved. That is how we able to solve the numerical, able to prove such kind of numerical. I hope it's understood to everyone. Now let us try the third question what we have. Okay, so we have just solved only two. Now we'll try to solve the third question. So what it says, we need to reduce in standard form. Okay, so they have given here the third question now, that is one, we need to reduce, sorry, they have given, they are saying we need to reduce what they have given, 1 minus 4i minus 2 upon 1 plus I. Now they have 3 minus 4i upon 5 plus I, and we need to reduce them to the standard form. Okay, to the standard form. So now standard form. Okay, so this is the third question I have. We need to reduce it to the standard form, and the question they have given. Okay, so now let us see how we can do this question now. In a very simple way, what they have given, this they have given. So let us first write the question, then we'll see how we can solve it. 3 minus 4i upon 5 plus I. What we can do it? Take LCM. So 1 plus I minus 2 into 1 minus 4I. So I have 1 minus 4I, 1 plus I. I we already know that it's iota. Okay. So we have this. So now what will be my next step? We'll multiply with 2 outside the bracket. We'll open the bracket now. 1 plus I minus 2 plus 8I. I have this 1 minus 4I and 1 plus I we have. So now what we can do here? We have 3 minus 4I upon 5 plus I. Okay. So now what we can do here? In a very simple way, it will be 8I plus I, 9I minus 1 plus 9I upon I have, for multiply now with this, we got 1 plus I minus 4I and minus 4I square. I have this 3 minus 4I, 5 plus I. Okay. So now what will be my next step? Let us see. They are saying minus 1 plus 9I upon, if I see this, that it will be 1 minus 3I, and here I square minus 1, so it will be 4. So I have this. So now what we got here? Minus 1 plus 9I upon 5 minus 3I. And we have this 3 minus 4I upon 5 plus I. So now what we can do here? Let's try to solve here. So now multiply inside. Okay. So this will be minus 1 plus 9I, 3 minus 4I upon 5 minus 3I, 5 plus I. So now I have this. Now we'll multiply. So it will be minus 3 plus 4I minus 27I minus 36I square upon 25. We have 25 plus 5I minus 15I minus 3I square I have. Now further solving it, we got what we got here, that is I square minus 1. So now we can arrange them. We have 31I plus 36, because we all know the value of I square will be minus 1. So we have this. Now here also will the same situation, 25 minus 10I, and here I square minus 1, it will be plus 3. So now what we have, we can prove here. So let us reduce this, remove this. Okay. So now we have, so what we can do here, let us see. Now we have this minus 3 plus 31, now what will have? 36 minus 3, 33, 33 plus 31I upon, we have 28 minus 10I. So we have this. So what we can do further? Let us rationalize this. So we have 31I upon 28 minus 10I into 28 plus 10I upon 28 plus 10I. Now I will rationalize. Okay. So now we will multiply, that is 33 into 28. So I have 4, 6, we have 924. Then we have this value plus 31 into 28. 4 have 868. 868I plus I have here, if I multiply now, I have got this 33. Wait. 33 into this plus I got 330I plus I have got this 868I plus 310 I square. Here I have 28 into 28, a minus b into a plus b, so it will be a square minus b square. So I have 28 into 28, it is just 784. 784 minus 100 I square. So I have this. Now I can say my answer will be what? Let us see what will be my answer here. So if I now put it will be I square. So it will be 924 plus, if I add this, I got 8I, I got 7I minus I will got 310 because I square value is minus 1. Now here I have 784, I minus 1, so it will be 100. So I got here, if I reduce this, so 416 plus 1198 I upon I got this 884. Okay, so if I need to reduce this, I can also do that. I upon 884. Okay, so I got this. If I need to reduce, I can reduce also to find the accurate value. You can reduce here. Here also I can reduce. So I got this 307 upon 442 plus 599 upon 442 I. Okay, so that is my answer. So like this we can easily reduce this in standard form, that is the normal complex number form. Okay, so we have. Now let us try to solve the fourth question. We have just solved only 3. Now we'll try to solve fourth. We just solved only 3. Now what the fourth question says, if fourth numerical is if we have, that is x minus iy is equal to a minus ib upon c minus id. Okay, c minus id. So now we need to prove, what we need to prove? Prove that x square plus y square whole square is equal to a square plus b square upon c square plus d square. Okay, so now how we can prove? Let us see. The solution is like this. What they have given? A minus ib upon c minus id. So now what we can do here? We'll need to rationalize. Okay, we'll need to rationalize now. So what we'll have? C plus id upon c minus id. So what we have here? If I solve this, I got AC, okay, plus IAD minus IDC. We have minus I square D square upon A plus B into A minus B. So I got A square minus plus it will be D square. under root I have. Okay, so I have this. A plus id b, or it is b, ib, c plus id. Okay, so now I have ac plus, if I multiply this, I got I ac plus I have IAD minus I have IBC minus here I got I square, then we have I square have BD I have. Okay, so now this is what I have. Now what we can do here, squaring both sides, squaring both sides, we get x minus iy whole square. I got AC. If I say, if I take this AC plus I, if I take common here, so I got AD minus BC minus I square, we know it's minus and plus BD. Okay, upon I have C square plus D square. Okay, now I open it, x square plus y square, I square minus 1, no? So minus, so I AC plus BD plus I AD minus BC. I can separate it here. Okay, so now I can separate it here. So now I can easily compare this. X square minus y square will be this. AC plus BD upon C square plus D square, and minus 2xyi will be I AD minus BC upon C square plus D square I have. Okay, so now further how we can solve? We know the formula here that x square plus y square whole square will be x square minus y square whole square plus 4 we have x square y square. Okay, because we know that if we square this will got this only, x will be minus 1, so it will be this. So we have this. Now what we can do, we can put the values here itself by squaring, no? So I got this. So we'll write here AC plus BD upon C square plus D square whole square plus I have 4. So this will be, we got whole square, no? So we'll square this. We have I square, well, now I have just compared this value here. So now we'll try to put the value of this. So we got here AD minus BC upon C square plus D square whole square. Okay, so I have this. So now what we can do here, we'll take the LCM here. So I got C square D square whole square. Okay, that we have. Now let us try to solve this. We got a square C square plus B square D square plus 2ACBD plus I have here A square D square plus B square C square minus we have 2ADBC. We'll reduce this. Okay, so now I have, that is, we'll take A square common here, so we have C square plus D square plus I have, we'll take common as B square, so we have C square plus D square, so upon I have C square plus D square whole square. Okay, so now we have, we'll take A square plus B square, because we will take C square plus D square as common, upon we have C square plus D square whole square. Okay, so if I reduce this, I got A square plus B square upon C square plus D square, hence proved. I hope it's clear to everyone. So that is how we are able to prove this. So this is the fourth question I have solved. Now I will try to solve the fifth one. So what the fifth one says, we need to convert the following in the polar form. Okay, so we have just solved the fourth one. Now we will try to solve the fifth one. So now we'll see what we can do here. The fifth question I have, we need to convert them in the polar form. That is, the question says convert the following in the polar form. So now how? Let us see. First, 1 plus 7i upon 2 minus I whole square, and second part they have given 1 plus 3i upon 1 minus 2i. Okay, so let us see how we able to convert them in the polar form. We'll take first part as first we'll solve. So we have 1 plus 7i upon 2 minus I whole square. What we can do here, in the numerator we can see there will be identity will apply, that is a minus b whole square, that is a square plus b square minus 2ab. Okay, so now let us apply. We have 4 plus I square minus 4i. So 1 plus 7i, we know that I square will be minus 1 minus 4i. So I have 1 plus 7i upon 3 minus 4i. So now what will be my next step? That is, we need to rationalize. So let us rationalize this. So I got 3 plus 4i upon 3 plus 4i. Now we'll multiply, we'll get 3 plus 4i plus 21i plus 28i square upon I have a minus 1 to a plus b. So it will be a square minus b square, that is 16i square. Okay, so we have here, that is, we have 3 plus 25i minus 28, because we know I square will be minus 1, upon I have I square minus 1, so minus 1 to minus plus, so we'll have 25. So I have here, that is minus 25 plus 25i upon 25, so I can write it as minus 1 plus I. So now we need to convert it in the polar form. How? We know that r cos theta will be minus 1 and r sin theta will be plus 1. Squaring and adding will be my next step. So what will be my next step? Let us see. R square cos square theta plus r square sin square theta will have 1 square plus 1 will be 2. So we'll have r square common square theta plus sin square theta, it will be 2. We know that sin square theta plus cos square theta will be 1. So we'll have r square is equal to 2. Therefore r is root 2. That is what I got by modulus. Now let's try to find the angle. We have r cos theta is equal to minus 1. So we have cos theta is equal to minus 1 upon root 2. And what we have sin theta here, if I apply r sin theta is 1, so we have sin theta is equal to 1 upon root 2. We know that in second quadrant sin is positive but cos is negative. So angle will be, theta will be pi minus pi by 4. We'll have 3 pi by 4. Okay, so the polar form will be r cos theta. R is root 2, cos theta is 3 pi by 4 plus I, r we know root 2, sin 3 pi by 4. So that is what I got my polar form now. So I can take root 2 common. So we have cos 3 pi by 4 plus sin I sin 3 pi by 4. Okay, so that is how we convert the function in the polar form. So now let us try to solve its next part. We have just solved first part. Now we'll try to solve the second part. I hope it's clear to everyone. So now what is my next part? Well, see. So my next part is 1 plus 3i 1 minus 2i. So now what we can do here? Now a simple form. Now we'll rationalize it. So 1 plus 3i upon 1 minus 2i, it will be 1 plus 2i upon 1 plus 2i. So it will have 1 plus 2i plus 3i plus 6i square upon 1 minus 4i square. So we know that I square minus 1, so it will be 1 plus 5i minus 6 upon I is minus 1 to 1 plus 4. So I have minus 5 plus 5i upon 5. So I have minus 1 plus I. Okay. So now let us try to convert it in the polar form. That is r cos theta minus 1 and r sin theta 1. Okay. So now squaring and adding will be my next step. Squaring and adding. So we get as r square cos square theta plus r square sin square theta will be 1 plus 1 2. So we'll take r square as common. So we have cos square theta plus sin square theta is equal to 2. So r square is equal to 2. So therefore r is equal to root 2. I got my modulus. Now we'll try to find that theta now. That is root 2 cos theta is equal to minus 1. So cos theta will be minus 1 upon root 2. Similarly, root 2 sin theta is 1. So therefore sin theta will be 1 upon root 2. Okay, so that is what we have. Now what we can do here is a similar thing. We'll try to find the theta here. That is same situation here. That is in second quadrant, sine will be positive and cos will be negative. So I have got this value. Now I will write it the polar form. That is root 2 cos 3 pi by 4 plus I root 2 sine 3 pi by 4. So I can take root 2 common here. 3 pi by 4 plus sine 3 pi by 4. Okay. So that is how we try to find its polar form. Now let us try to solve the sixth question. We have just solved only 5. Now what the sixth question says? Let us see. The sixth question is my hand. That is we need to solve. Okay. We need to solve the following equations. Okay. So what the first equation says? That sixth question. 3x square minus 4x plus 20 upon 3 is equal to 0. Okay. So we need to solve the equations. How? We'll take LCM first. 9x square minus 12x plus 20 upon 3 is equal to 0. So now I have the equation that is equal to 0. Okay. So now we'll try to solve. 12 plus minus, we'll try to apply the class 10th formula here. So we have 3x square minus 4x plus 20 upon 3. So now very simple thing they have given. We'll have b square on 44 minus 4 into 9 36 into 20 4ac upon I have 3. No, upon 2a, sorry, so 2a it will be 18. So we have 12 plus minus will have 144 minus 720 upon I have 18. So here 12 plus minus, we know the value that it will be 5 and 6. No, it will be 5 then. Okay, so it will be 5, 5, 6 minus. Okay, we know that when we reduce this, so we got 20, and we so we got this. Okay, so if I add 5, 5, 6, 144, 700, so it will be 576. Okay, so I have this 576 upon 18. Now we know minus 1 in the under it will be I. So we'll have 12 plus minus 576 I upon 18. So I have 12 plus minus, now we know that 576 it will be root 24 I upon 18. So reduce by 6, we got 2 plus minus 4 I. Okay, I've taken 6 upon it will be 3. So that is how we try to solve the following equation. Okay, now we'll try to solve the next, that is we need to solve the following equation. So how? Let us see. The equation is x squared minus 2x, x squared minus 2x plus 3.2 is equal to 0. So this is the equation they have given. Okay, let's try to solve it. Take LCM first. So we have 4x plus 3 upon 2 is equal to 0. So I have 2x square minus 4x plus 3 is equal to 0. Now we'll try to apply the quadratic formula here. So we have x is equal to 4 plus minus b square 16 minus 4 into 3 into 2 AC upon 4. So I have 4 plus minus 16 minus 24. So I have 4 here. So now 4 plus minus 8 under root upon 4. So 4 plus minus, we have 8 I upon 4 will be 4 plus minus 2 root 2 I upon 4. We can take 2 common here. So we have 2 plus minus root 2 I upon 2 will be there. We have reduced, we have taken 2 for common from the numerator, and we have denominator, we have 4. So it will be left with 2. So we can write as 1 plus minus root 2 upon 2 I. Okay, so that is how we try to solve the following equation. So let us see what is the next equation we have. We have just solved only 2. So we have solved 7 questions from this miscellaneous exercise. Okay, so now what the 8 says, 27x square, we have 27x square minus 10x plus 1 is equal to 0. Okay, so we have this. Let us try to solve. X is equal to 10 plus minus b square, that is 27 into 27. So we have 729 minus 4 into 27 into 1. Okay, so we have this upon, that is we have 54. So we have 10 plus minus 729 minus 108. We have this upon 54. Let us confirm the equation. 27x square minus 10x plus 1 is equal to 0. So we have minus b plus minus b square minus 4 into A into C. So I have this 10. Okay, so let us first confirm 13, 14, 5, same 9. Perfect. So now what we'll have here, from minus this, I got 621 upon 54. Okay, so this is what we have here. So we can, if I want to leave, you can leave it this as. Okay, so now see, we have positive form, so we don't find any iota in this. Okay, so this is our equation. Okay, I will confirm this question if it is whether it is right or not. Let us move on to the next one. So now the next question, next equation we need to solve: 21x square minus 28x, okay, plus 10. Okay, let us try to solve. 28 plus minus b square. Okay, 28 into 28. So we have 2, 16, 5. So we have 4, 7. 784 b square minus 4 into 21 into 10. Okay, so I have this 42. So we'll have 28 plus minus 784 minus we have 21 into 4. We have 4 to the 4, 4 to the 840. Okay, so I have this upon, now we have 42. So we have 28 plus minus. Now what we have here, we're left with 16 plus 40, 56. Okay, but it will be minus upon, we have 42. So we know the minus 1 value in the under root will be I. So we have 28 plus minus 56 under root I upon 42. Okay, so now I can reduce this by, we know that 56. Okay, if I reduce this 14, 2 into 7, 7 into 1, so we have, okay, so I can take 2 common, so I have 14 the root I upon 42. So I can reduce by 2, we have 14 plus minus root 14 upon 21 I. So I can do that, 14 upon 21, 2 upon 3 plus minus root 14 upon 21 I. Okay, so that is how we try to solve the following equation. Now let us see how to solve the 10th question now. Now what the 10th question says, let us see. They have given if z1 is equal to 2 minus I and z2 is equal to 1 plus I. Okay, so they have given two complex number. Now what we need to do? We need to find. Okay, what we need to find? z1 plus z2 plus 1 upon z1 minus z2 plus 1. Okay, so we need to find this. Okay, so now let us see what we can do here. Very simple solution we have, that is, we'll try to put a value here, that is 1, we have 2 minus I plus 1 plus I plus 1 upon 2 minus I minus 1 minus I plus 1. So it will have 4 upon, if I reduce this to 1 minus 1, so we have, what we will have here, 2 plus 1, 2 plus 1, 3 minus 1, 2. 2 minus 2i. Okay, so I have this 4, I can take 2 common, 1 minus I. 2 I have, so now I can do it, 2 upon 1 minus I So it will be 2 upon 1 minus I into 1 plus I, 1 minus I. So it will have 2 into 1 plus I, a square minus b square. A square minus b square will be that is 1 minus I square to plus 1. So we have this. So I have this. Now we need to find its modulus. So we'll have square will be root 2. Okay. So that is how we able to find its value. Okay. So we have. Now let us try to solve the next question, 11th. Let us see what they have given. We have just solved half of the miscellaneous exercise till now. So now let us try to solve the 11th. That is, they have given if a plus ib, that is, they have given if a plus ib is equal to x plus I whole square upon 2x square plus 1, then we need to prove. Okay, so what we need to prove is that is a square plus b square is equal to x square plus 1 whole square upon 2x square plus 1 whole square. Okay, so we need to prove this. So now we have the solution now. That is, they have given a plus ib is equal to x plus I whole square upon 2x square plus 1. So they have given the question list. Now let us try to solve. What we can do here? If I open this, x square plus I square plus 2xi upon 2x square plus 1. So we'll have x square I square, we know, minus 1 plus 2xi upon I have 2x square plus 1. Okay, so now I have this. So that is what we have, I plus ib. So now I can write this as x square minus 1 upon 2x square plus 1 plus 2x upon 2x square plus 1, that is I. So I can say a we have x square minus 1, 2x square plus 1, and b we have 2x upon 2x square plus 1. Okay, so that is what we have. Now we need to find the a square plus b square. So let us try. A square plus b square will be x square minus 1, 2x square plus 1 whole square plus I have 2x upon 2x square plus 1 whole square. So if I take the LCM here, that is 2x square plus 1 whole square. Okay, so it will be x square minus 1 whole square plus 4x square. So it will be, take the LCM here, I got x4 plus 1 minus 2x square plus we have 4x square upon I have 2x square plus 1 whole square. So here I have x4 plus 1 plus 2x square upon 2x square plus 1 whole square. So I can write here x square plus 1 whole square upon 2x square plus 1 whole square. Hence proved. Okay, so that is how we try to prove the question. Okay, so now we'll try to solve the 12th question now. We have just solved 11. So now what we have the 12th. Let us see. They have given, that is, z1 is equal to 2 minus I and z2 is equal to minus 2 plus I. So what we need to find, let us see. What we need to find, that is first one, we need to real number z1 z2 upon z1. Okay, so we have this. Okay, we have this one. Okay, so we need to find this. In second part, we need to find imaginary number 1 upon z1 z1. Here we have to. Okay, so now let us see how we'll able to find this. Let us solve. For first part we have, that is z1 z2 upon z1. So now what is z1 z1 we have 2 minus I, and z2 we have minus 2 plus I. Okay, so let us try to find this first, that is z1 z2. So we have minus 4 plus 2I, we have plus 2I, we have minus I square. So what will happen here? We'll have minus 4 plus 4I minus I square minus 1, so plus 1. So we'll have minus 3 plus 4. Okay, so we have this. So now we need to find the value here, that is we have this z1 z2. Okay, so now what will be, z bar will be 2 plus I. Okay, so my value for that real number z1 z2 upon z1 bar, what it will be, the product will be minus 3 upon z1 bar, z1, so it will be 2. So that is my answer. Okay, because they are asking about only the real number, so we'll take that real number only. Okay, so that is what I have. Now the second part for the same question I have. So the second part will be, we'll need to find imaginary one, na? Imaginary, that is 1 upon z1 bar. So what is z1 we have? Z1 we have, first find 2, z1 we have 2 minus I, z1 bar will be 2 plus I. Let's multiply first. So z1 bar will be 2 minus I, 2 plus I. A minus b into a plus b, a square minus b square. So 4 minus I square. So 4 plus 1 will be 5. So if I talk about its imaginary number, it will be 0. So imaginary number of 1 upon z1 bar, it will be 0. Okay, so that is how we try to find the answer. Now let us try to solve the 13th question. Okay, so we have just solved only 12. Now let us see how we'll able to solve the 13th. What the 13th question says. The 13th question is in a very simple way, that is, we need to find the modulus and argument. We need to find the modulus and argument of the complex number. Okay, of the complex number, that is 1 plus 2i upon 1 minus 3i. Okay, so we need to find a modulus and argument of that given complex number. Now let us see how we can solve. So this is a 13th question. Now I am taking from the miscellaneous exercise. So okay, we have solution here, that is the complex number they have given 1 plus 2i upon 1 minus 3i. Okay, so how to solve? Let us see, rationalize it. Okay, first step is to rationalize. So they have given in this, that is a plus b, 1 plus 2i into 1 plus 3i upon a plus b into a minus b, a square minus b square, 9i square. So you can multiply inside 1 plus 3i plus 2i plus 6i square upon minus I square will be minus 1, so it will be 1 plus 9. So I have 1 plus 5i, I square minus 1 to minus 6 upon 10. So I have minus 5 plus 5i upon 10. So I have minus half plus half I. So this is the complex number I have got. Now I need to find its modulus and argument. So now we will try to find, we have r cos theta is equal to minus half and r sin theta is equal to half. So now squaring and adding will be my next step. Squaring and adding. So now I got here, that is r square cos square theta plus r square sin square theta is equal to minus half square plus half square. Okay, so now r square will be taken common, so we have cos square theta is equal to 1 by 4 plus 1 by 4, so it will be have half, so we'll have, therefore r square will be 1 upon 2, therefore r is equal to 1 upon 2. So finally I able to find the modulus, that is 1 upon root 2. Now to find the argument, so now we'll try to find the theta first. So now 1 upon root 2 cos theta is equal to minus half, so cos theta is equal to minus root 2 upon 2. Okay, so it will be cos theta is equal to minus root 2 upon 2. Now what we can do, we have this, and for that cos theta, that is for r sin theta. Okay, so we have find this. So 1 upon root 2 sin theta will be half. So we'll solve this. So we'll got sin theta is equal to root 2 upon 2. Okay, so we have this value. Let us see. So now what we got here, that is cos theta will be, that is minus 1 upon root 2. Okay, and sin theta will be, that is 1 upon root 2. So now to find the theta here, that is we know that in second quadrant sin is positive and cos is negative. So we'll have pi minus pi upon 4, it will be 3 pi upon 4. So we have argument, that is theta 3 pi upon 4, and modulus we have 1 upon root 2. So that is how we find the modulus and argument of the given complex number. Now let us try to solve the 14th question now. Okay, so now let us see what the 14th question is given. So they have given 13th question, 13th हो गया, 14th. Now let us try to solve the 14th question now. What it says, that they have given, find the real numbers x and y if x minus iy into 3 plus 5i is the conjugate of minus x minus 24i. Okay, so let us try to find the real value of x and y. So what they have given, that this is the conjugate of this. So x plus iy 3 plus 5i is the conjugate of this. Okay, so let us see, 3x, let's multiply, plus 5xi plus 3iy plus 5yi square. So I got 3x, here I square will be minus 1, so minus 5y, plus we have, if I take I common, so 5x plus 3y, we have y. We have I solved here. This is, so finally I have got this is the real number and this is the imaginary number. Now they are saying that this is the conjugate of this, that is minus 6 minus 24i. Okay, so this is what we have got. We can consider this as 5y is equal to minus 6 and 5x plus 3y is equal to minus 24. Okay, we'll compare real number and imaginary number here. Okay, so we have, so now we have, that is plus, because they are considering the conjugate of this. So now we'll try to solve these two equations now, first and second. So now what we can do here, multiply with 5. So I multiply first equation with 5. We know we have studied in class 10th how to solve two equations by different methods. So I am applying here a method to solve this equation, that is elimination. So now multiply with this. So I got multiply first with equation 5 and second equation with 3. So what will I got here? 15x minus 25y minus 30 and 15x plus 9y is equal to, we have 24 into 72. Okay, so now we'll subtract it and I got here minus 34y is equal to, we have minus 102. Okay, so now what I got, so what I got here, y is equal to 102 upon 34. If I divide this, I got 17, 6, 3. So we got 3 here, y, and putting the value of y in this, so what we got, 3x minus 15 is equal to minus 6. So 3x is equal to 9x is equal to 3. Oh wow, so we find that x is equal to 3 and y is equal to 3. Okay, 15, 6, 9. So that is how we able to find the real values of x and y, because this is given that this is the conjugate of this. Now let us try to solve 15th question from the miscellaneous exercise. So we have just solved 14. Now let us try to solve 15th. 15th. Now what they have given in this 15th question, that is, we need to find the modulus, okay, of this function they have given, 1 plus iy upon 1 minus I minus 1 minus I upon 1 plus I. Okay, so we need to find the modulus of this. Okay, so let us try to find. How to find? Let us try to solve this. I hope it's clear to everyone. So now let us try to solve this. So I got, let us take LCM here, 1 minus I, 1 plus I, we have 1 plus I whole square minus, we have 1 minus I whole square. So next step will be 1 plus I square plus 2I minus 1 plus I square minus 2I. Okay, a plus b into a minus b will be a square minus b square. So 1 minus I square. So we have 1 plus I square plus 2I minus 1 minus I square plus 2I. So what I got here, I'll reduce all, and I square means I square 1 minus 1, so it will be 2. So we have 2I plus 2I, 4I upon 2, 2I. So I got 2I. So now to find its modulus, if I try to find, it will be 0 plus 2 square. We have, so it will be 4, it will be 2. Okay, so that is how we try to find the modulus like this. Okay, so we have this. So we have solved 15 questions now. Now let us try to solve the 16th one. So let us see what they have given in that case. So now we have the 16th question. So what is the 16th question is, if x plus iy whole cube, if x plus iy whole cube is equal to u plus iv, okay, then show that, okay, we need to show, then show that u upon x plus v upon y is equal to 4 x square minus y square. Okay, so let us try what we have given in this. That is, they have given x plus iy whole cube is equal to u plus iv. So now let us try to put the formula for a plus b whole cube. That is a cube plus b cube plus 3ab into a plus b, okay, is equal to u plus iv. So now what I have here, x cube, so I cube we have, so I can write it is as I square into I. Okay, I can write this like this, plus I have 3xy x plus iy, u plus iv. So now I got here x cube. Now I square means minus 1, so we have minus y cube I plus, and multiply inside 3x square yi plus 3xy square I square is equal to u plus iv. So now I got here x cube, so I square will be minus 1, okay, so 3x square yi minus 3xy square is equal to u plus iv. Now x cube minus 3xy square plus, if I consider this, we'll take I common, so we have 3x square y minus y cube, so we have I is equal to u plus iv. Okay, so now comparing, I got u, that is x cube minus 3xy square, and I got v, that is 3x square y minus y cube. Okay, so now let us try this. We have u here, so if I try to solve LHS first, okay, so now let's try to solve LHS. So now what we have, that is u upon x plus v upon y. So what will have, if I divide x cube minus 3xy square by x plus 3x square y minus y cube upon y. So now let us try. If I take x common here, I got x square minus 3y square, and here also I will take y common, so I have 3x square minus y. So what I got here, x square minus 3y square plus 3x square minus y. So I have this x square plus 4x square minus 4y square. I can take 4 common, y square. What I needed in that case. Okay. So that is how we try to solve this question. Now let us try to solve the next question we have. I hope it's becoming clear to everyone, that is how we able to solve numericals. This is the miscellaneous exercise from the complex number I am solving. So I have just solved 16 questions. Now let us try to solve 17th. What they have given, let us see. So what does 17th question says? They have given, that is, if alpha and beta are different complex numbers, okay, different complex numbers, then, and they are saying They are saying with beta is equal to 1. Okay, then we need to find a value of beta minus alpha upon 1 minus alpha beta. Okay, so we need to find a value of this. And they are saying that is alpha and beta are two different complex numbers. Oh my god. So now what is they have given in this? They have given alpha and beta. Let us take alpha and beta here. That is a plus ib and beta is equal to x plus iy. Because they are saying that both are different complex numbers. Okay, so let us see how we solve. Now let us try to solve. Now they are saying that beta is that is x squared plus y squared is equal to 1. So this is the first equation. Now what they have given, beta minus alpha upon 1 minus alpha beta. So let us try to find this value. How? Let us see. So they have given beta, that is x plus iy minus alpha a plus ib upon they have 1 minus alpha, the conjugate they have given alpha, so we will take a minus ib x plus iy. Okay, so now let us try to elaborate it. So I got x plus iy minus a minus ib upon 1 minus, now if I try to take this inside, that is ax plus ayi minus ibx minus I square by. Okay, so now I am taking this as, so now what will happen, we'll separate real numbers and imaginary number separately. So I have x minus a. Okay, x minus a I have, so we'll take plus y minus b iota upon, I have 1 minus, let's try to solve this, ax plus ayi minus ibx minus, now we have this I square means minuses, so plus by. So now let us try to write more. So I have x minus a, so what do we have, x minus a plus I y minus b. Now in denominator I can solve like this, we have 1 minus ax minus by, and inside I have plus I am taking ay plus bx. So I have this. Okay, so now what I have solved, that is ax minus by, and here I have taken the ay minus we have minus. Okay, so but if I try this, so I will take minus here, so that it will be plus. Okay, so I have taken this. Now what I can do here, let us try to solve it further. Now let us take the modulus. Now how to solve this, we'll take x minus a whole square plus y minus b whole square under root. Now I have 1 minus ax minus by whole square under root plus I have bx minus ay whole square under root. So now we'll try to separate it. We have x square plus a square minus 2ax plus y square plus b square minus 2bx under root I have. Okay, so this is what I have. Now upon, we'll take the similar case. Here we have a plus b plus c whole square, a square plus b square plus c square. Now we have in this, that is minus, so we'll take as minus 2ax minus 2by. Okay, 2ax, okay, minus 2by, and plus I have here. Okay, what is there? Now what we have here, minus 2x plus 2abx minus 2by plus, okay, now plus it will be b square x square plus a square y square minus 2abxy. Okay, this whole goes in one root now. Okay, so now we have this in whole goes in one under root. So now we'll try to write here what we can do here. We can take x square plus y square separately, and we have plus a square plus b square minus 2x minus 2b, 2ax minus 2bx. Okay, now we have this in under root. Upon we have, let us see what they have given in this. Here also we'll try to solve this. What will happen, we'll take a square common. So if I take a square common here, or instead we can take x square common. So what we'll take, let us see what they have given. Okay, we'll take a square common. So we'll have x square plus y square. We have x square plus y square, then we'll take plus b square as we have b square x square plus y square we have. Okay, then we have the same thing, minus 2ax we have, then here we have this value. So plus 2abx y we have here. Let us see how we can solve this. So we have, now it will be reduced by this. So we have left here minus 2ax, okay, then minus 2by. Okay, so now why I have done this, because now we know that x square plus y square is 1. So I can write that 1 plus a square plus b square minus 2ax minus 2by here. So we have this. So now here is y. Okay, upon I have in this 1 plus a square plus b square minus 2ax minus 2by. So but I found this the similar one, so I got 1. Okay, so that is how we try to prove that we need to find that value. What I got here, that is 1. So that is how we try to solve the question. Now let us try to solve next question. Just we have solved only 17. So now we'll try to solve the 18th one. Let us see what they have given in this. We have just solved 17 questions from the miscellaneous exercise. Now let us try to solve 18th one. What the 18th question says. Let us see what the 18th question says. That is, we need to find the number of non-zero integral solution of the equation, that is, I have given 1 minus I x we have is equal to 2 raised power x. Okay, so let us see how we can easily solve such kind of question. What they have given in this, that is, we need to find the number of non-zero integral solution of the equation. So we have this 1 minus I x, we have 2 raised power x. Okay, so what we can do here, they are saying about the modulus of this will be 1 square plus 1 square negative under root we have, that is x is equal to 2 raised power x. So now 1 plus 1 we have whole power x is equal to 2 raised power x. We have 2 raised power x upon 2 is equal to 2 raised power x. So we have x upon 2 is equal to x. We can take x is equal to 2x. We can take 2x minus x is equal to 0. So we have x is equal to 0. So that is, the 0 is the non-zero integral solution of the equation. So we can write, therefore 0 is the only integral solution of the equation. Okay, so that is how we are able to find. Let us try to solve 19th question now. Now, what the 19th question says? The 19th question says, if a plus I beta, okay, C plus ID and E plus IF and G plus IH is equal to A plus IB, then show that, okay, the question says then show that, what we need to show, that is A square plus B square C square plus D square E square plus F square G square plus H square is equal to A square plus B square. Okay, so they have given the question here. So let us see how we able to solve this, that if A plus IB into C plus ID into E plus IF into G plus IH is equal to A plus IB, then show that A square plus B square into C square plus D square into E square plus F square into G square plus H square is equal to A square plus B square. So let us try to solve this. Now let us see how we can do this. A plus IB, C plus ID, E plus IF, G plus IH is equal to A plus IB. Now what we can do? A plus IB, C plus ID, E plus IF, G plus IH is equal to A square plus B square, or else what you can take instead in that case. Okay, so now what we can do here, A plus IB into C plus ID into E plus IF into G plus IH is equal to A plus IB. Okay, so now what we can do here, we can write like this: A plus A square plus B square C square plus D square into E square plus F square into G square plus H square. I can write like this. Okay, A plus IB. Right, now squaring both sides. Okay, what we can do, squaring both sides, we get, okay, so what we get here, that is A square plus B square C square plus D square E square plus F square G square plus H square is equal to A square plus B square. Okay, which is required in that question. That is hence proved. So that is how we try to prove that question. Okay, so we have one more question in this exercise. Let us see what they have given. Very easy question. Now they have given the last question of this miscellaneous exercise. So let us see how we able to solve this. So let us see what we have. That is 20th question I have. They are saying if 1 plus I over 1 minus I raised power m is equal to 1, then what we need to find, the least integral value of m. Value of m. Okay, so this is the question we have. Let us try to solve. Very easy question they have given. What we can do, let us write 1 plus I upon 1 minus I raised power m is equal to 1 they have given. So we can write as 1 minus I into 1 plus I 1 minus I. So we have given this. So m is equal to 1. So they have given the question like this. So now let us try to find I1 plus I whole square, and here we have a square, a minus b into a plus b. It will be a square minus b square, 1 minus I square. So this is what they have given. So we have 1 plus I square plus 2I upon I square will be minus 1. So 1 plus 1 will be 2. M is equal to 1. So we have 1 minus 1 plus 2I, because we know I square will minus 1 upon 2 is equal to 1. So I have 2I upon 2 is equal to 1. So I have here I raised power m is equal to 1. Okay, so I got the value here, I raised power m, I got 1. So what we can do here, if I try to put the value I raised power m is equal to I raised power 0, so m will be 0 here. Okay, so able to find that is 0 is the least integral value of m. Okay, so I hope it's clear to everyone. So if you have any doubt regarding the complex number, you can ask, comment, and also please share my channel, and also like